GM, everyone. I'm Dean. I'm a cryptography researcher, open source developer, and affectionately referred to as a quantum cat by Meow over there. By the way, he's also a pain in the ass. But so everyone knows, like, Solana's North Star is increase bandwidth, reduce latency. But we have a slightly different goal. We want to build the SVM that people want to fork. You see, we are thinking, how can we build the SVM that unlocks all these use cases of advanced cryptography to enable powerful user applications, as well as cross-chain transactions, and all sorts of use cases that are not typically as well served by blockchains that prioritize performance over functionality. And so this is a really huge opportunity for us to basically be able to play around with some really cool new things that are actually possible on blockchain today. So today I'm going to be speaking about 4 things. So delegation, ZK identity, BLS signatures, and state attestations. So I'll start with a new primitive that we are still in the process of designing, but are considering to introduce to JupNet, called the Delegate program. We asked the question, what if users didn't have to custody a private key? How many people here have gone to onboard people? You send them $5 of crypto and say, hey, go and do a Jupiter swap or something, right? But then they lost their wallet or they lost their phone and their funds are gone forever, right? So what if we had a way to enable account recovery that was permissionless and non-custodial? See, self-custody is extremely based. And I recommend everyone here to engage in self-custody if you can. But losing private keys sucks. It hasn't happened to me, but I've got a lot of friends who have lost a lot of money from losing their private keys. As you can see here, right, we have a wallet with 1000x gains from a popular meme coin in it. And the only thing stopping you from unlocking it is a scrap piece of paper that you scribbled down 12 words on some time ago, and it's now gone forever. What if we could replace that with something that enables you to choose a way of recovering your account? You could use a multisig. You could use passkeys on your iPhone or your laptop. Or you could even use social recovery. You could select who are the people who can help you to recover your wallet. So we've put some thought into how we could accomplish this in an efficient manner. And we came up with the Delegate account. So it's very simple. It just has 3 fields. We have the delegator, the account that we're going to be able to sign for as a delegate signer, the authority, who's able to update the session key, and then the session key. So how it works is an authority, it can be delegated to a PDA of a program. And by virtue of belonging to a PDA signer, we are able to have an infinitely composable set of conditions by which we can roll the session key. So let's say that you lost your private key, right? Well, on our chain, we're going to have SCP-256-R1. You'll be able to use your passkeys on your laptop as a recovery method to sign on behalf of this wallet, and you'll be able to basically just continue to have access to your funds. And so essentially how it works is the creator would invoke the create process, which would basically just say, as the signer who owns this account, I delegate the ability to update my session key to this program and set my session key to this. And then from that point on, in a new transaction version, we are able to use this account to sign on behalf of that account. We're essentially tricking the system into believing that they signed with the main key, but we are using a delegate key. And there's only three instructions at this point: create, update, and revoke. For the signer, the session key, it is essentially at parity with the main account, with the only difference being that this account can be revoked, whereas the main account signing authority cannot. So it always is the highest the highest rank in terms of signing. And so basically, you can create a delegate account with your own key. It's very simple. This code, you can see, is extremely simple code. You sign, you update, and that's it. For the update, we basically delegate this off. You'll see here in the Delegate account, we are requiring that the authority key belongs to the Delegate account authority key. And so as long as you've delegated to the right program or the right signer, then they're able to have access to update your session key. So if you use a permissionless program that's able to use some recovery methods that are trusted, such as, let's say you had like, maybe you're using a squads wallet, or maybe you're using some kind of social recovery where you said, these 3 friends together can help me recover my funds. You can have deterministic ways so that they can only update the session key and nothing else bad can happen. And the cool thing is because it's PDA signed, it's compatible with our upgraded cryptography. So you can use it with passkeys or BLS signatures, ZK proofs, as well as also RS-256. RS-256 is very powerful, and Siji is going to go into that in a bit. So then I'll bring you to the next topic, which is ZK identity. What if you didn't have to dox to prove your identity? What if you could know I'm me without knowing who me is? Well, I'll start by what is like the RS-256 stuff that I just mentioned, right? Because we have Big Mod EXP enabled from day one, social login is now here. We're able to verify RSA signatures natively on-chain using the Big Mod XP syscall. Unfortunately, this is not enabled on certain other chains, but we have enabled it so that we can unlock one of the biggest use cases, which is RSA 2048, which is the most commonly used signature scheme in the world, and also what powers Google and Apple's OpenID authentication flow. So we can verify that you own a Google or an Apple account, right? But what if you don't want us to know what your Apple account is? Or what if you don't want Apple to know that you have a blockchain account? Well, we can actually obfuscate that information using a ZK proof in the middle. So then we have a very powerful primitive here where on the one end, we can actually verify your identity provably from your social media presence. And on the other hand, we can leverage your social media to anonymously verify that you are the same person who has previously logged in. So you get to either use it as a proof of identity where you do docs, or a proof that you are who you say you are without someone knowing who you are. Now I bring you to BLS signatures. Tiny signatures, massive potential. A lot of the things on JupNet are powered by BLS signatures and aggregation. I'm going to go into a little bit of how that works. So when you sign with an arbitrarily aggregatable signature scheme, such as BLS signatures, if you take key 1 and key 2 and add them together, they equal key 3. If you take signature 1 and signature 2 and add them together, they equal signature 3. And then it is as though a third private key that neither of you own signed a signature that you're able to verify from a third public key that neither of you knew until you put your keys together. And for any single message, we're able to arbitrarily aggregate these signatures. This QR code right here is actually the open source library that we actually are using at JupNet. This is already available if you're a dev. If you missed it, you can go back and watch it on YouTube. But yeah. So to break down what is BLS, the very simplest way I can put it is it's an efficient proof that any number of people agree about something, right? And so that unlocks some very powerful things. For example, you can apply it to consensus. You can apply it to oracles. You can apply it to have more efficient perps. You can do this by aggregating from multiple sources of truth and having a stronger, more trustworthy overall architecture. So let's think about how we might do this. Is the price of Bitcoin over 100K right now? What's that? Oh, you just got perps. Do we agree that this is the latest valid block? You just got consensus. Did someone just deposit 5 Bitcoin onto JupNet? You've got oracles, bridges, and proof of reserve. And this is how we are powering the Omnichain future, by being able to aggregate not just the world's transactions, but also signatures and public keys that are verifying that information. We're able to create succinct proofs of everything. Aggregate everything, verify anywhere. the last thing I want to talk to you about is state attestations. You see, if we're using BLS signatures as our security mechanism, there's this other really cool property where if we design our chain in a way that the incoming transactions can be proven based upon signing consensus, and the outgoing transactions can be proven based upon signing consensus, then our consensus can also be proven on other chains. So it enables us to actually open a door for other chains to integrate with us. If we can leverage consensus, that means that we can prove not just that this is a valid block, but we can reuse our existing validator infrastructure to prove all kinds of things, like, do they have the funds? Does this withdrawal exist? Or did someone make a deposit?